Now it comes to the problem statement. Most of the proposed architecture is work for only one video coding standards. For example, either HEVC or AVC. However, there are some similarities on the filter operation for both HEVC and AVC which can be combined. Normally, the resource utilization rate is high when the proposed architecture only works for one video coding standard. So is it possible to implement a combined inload filter to be used for two video coding standards with the design that has lower resources utilization rate and better performance compared to the individual inload filters? So my objectives are to validate the functionalities of the individual and unified AVC and HEVC inload filters, to evaluate the implementation cost and performance of the individual and unified AVC and HEVC inload filters. The limitation of the project are all the design only can work on 64 by 64 image, and user need to select either HEVC or AVC in combined design instead of producing two output image at the same time. Boundary strength calculation is done by assumption, as the boundary strength for each HEVC and AVC are justified by condition. Why the solutions that I propose is better? Because the suggested combined inload filter is a completely brand new idea, as no one has ever attempted it before, and the proposed combined inload filters are proven to have better performance than the two individual inload filters in terms of power consumptions, as it consumes lesser power but giving the same subjective quality of the output image. As we convert our image into 64 by 64 using MATLAB, the text file is called input pin. Then after that, we fetch the input pin text file to our VNC. Then we do for the VCS for individual AVC. So after we done the VCS, we fetch back the output image file from the individual AVC to our desktop. Then we continue do for the individual HEVC. Same process, we use the input pin text file in our VCS. Then after we done our VCS, we fetch the output text file of the individual HEVC back to our desktop. Then we continue do for the combined design. So this time the user choice is equal to 0. That means HEVC is selected. So you can see from the test bench, the user choice is equals to 0. That means HEVC is selected. Same process, after we done the VCS, we fetch the combined design when user choice is equals to 0, HEVC output back to our desktop. Then we repeat the process, but the user choice is equal to 1. That means AVC is selected. So you can see from the test bench again, the user choice is equals to 1. That means AVC is selected. So same process, we run for the VCS. Then after we done the VCS, then we fetch the AVC output to the desktop. Then after that, we back to the MATLAB. We use the combined design and the individual design when both of them are work for the AVC. So this one is the image. Then this one is our BSNR ratio. Then we repeat the process again, but this time is the HEVC. So this one is the image. Then this one is the PSNR ratio. The target segment for this project are the proposed architectures are applicable to all the devices that support video codec, such as mobile devices, televisions, laptop, cameras, and etc. So that's all from me. Thank you very much.